Hello students, welcome to the class RK Physics. In the previous class, we are doing some previous year MCQs and their solutions. In this class, we are also doing some questions based on the alternating current which are asked in the CHSE Odisha. So the first question is given by the peak value of an AC of 2 ampere in a circuit is. So the current is given by the RMS current in the AC circuit is given by 2 ampere. So we can calculate the peak value of the current. The question is given that the RMS of value of a current is 2 ampere. Find out the peak value of the current, that is I0. We have to determine the I0. As we know that the relation, that is IRMS equal to I0 by root 2. IRMS equal to I0 by root 2. Then I0 equal to IRMS into root 2, that is IRMS is equal to 2 into root 2 ampere. RMS value of current here given that 2 ampere root 2. So peak value of the current is equal to 2 root 2 ampere. The next question also given that in an AC circuit the current is given by the relation I is equal to 100 root 2 cos 50 t ampere. Find the RMS value of the current. The current relation is given by 100 root 2 cos 50 t ampere. We have to determine the RMS value of current. In this question, the relation is given that I equal to 100 root 2 cos 50 t ampere. As it is compared with the standard equation, I equal to I naught cos omega t. So I naught is given by comparing the above two equations. Assume that this is equation and this is equation 2. This is the standard equation. This is the standard AC equation. You can write down that is I0 cos omega t or I0 sin omega t. Is comparing the two equations, we can calculate the peak value of the current is 100 root 2. That is the peak value of the current, 100 root 2 ampere. Now we can calculate the RMS value of current according to the relation I0 by root 2. IRMS equal to I0 by root 2. Is comparing the equation, we have got I0 equal to 100 root 2 divided by root 2. That is root 2 cancel, 100 ampere. So the RMS value of the current in the AC circuit is 100 ampere. That is the answer. In another question, it is given that in an AC circuit containing resistance only EMF and current are given by E equal to 200 sin 200 t volt, I equal to 100 sin 200 t milliampere. Comparing with the two standard equations, EMF equal to 200 sin 200 t volt, that is the EMF standard equation equal to E0 sin omega t. E is equal to E naught sin omega t. And another equation is given by I is equal to 100 sin 200 t milliampere. Here you convert the milliampere into ampere, that is 100 into 1 milliampere equal to 10 to the power minus 3 ampere sin 200 t ampere. Here milliampere is converted to 10 to the power minus 3 ampere. 1 milliampere equal to 10 to the power minus 3 ampere. So we can write down 100 into 10 to the power minus 3 sin 200 t ampere. Comparing with the standard equation, I is equal to I naught sin omega t ampere. So from the above two equations, comparing with the EMF and current, we can calculate the peak value of the current and the peak value of the EMF. From comparing the peak value of the EMF equal to 200 volt and comparing the peak value of the current equal to 100 into 10 to the power minus 3 ampere. So the power dissipated in the AC circuit is given by the power dissipated in the AC circuit average power is given by E naught I naught cos phi, sorry, ERMS IRMS cos phi. Formula is equal to ERMS IRMS cos phi. Here phi is the phase difference in an AC circuit containing resistance only. The phase difference between EMF and I current is 0 degree. In resistance in an AC circuit containing resistance only, the phase difference between EMF and current is 0 degree, because here the EMF and current are in the same phase in only resistance. In an AC circuit containing only resistance, that is the phase difference between EMF and current equal to 0 degree. So we can write down average power dissipated equal to ERMS IRMS cos phi, that equal to ERMS is equal to E naught by root 2, IRMS is equal to I naught by root 2 cos phi. E naught I naught by 2 cos phi. So E naught value we can calculate 200, I naught equal to 100 into 10 to the power minus 3 by 2 cos phi equal to cos 0. So 200 into 100, 2 into 10 to the power 4 into 10 to the power minus 3 by 2 cos 0 degree. That is equal to 2 into 2 to cancel, 10 to the 4, 10 to the minus 3 is 10 cos 0 degree. That is 10 into cos 0 equal to 1, that is 10 watt. That is the answer, the average power dissipated in the circuit. Thank you. In the next class we can doing some other problems based on AC.